Good afternoon, and webinar on fire safety and materials on high-rise buildings. I'm Martin Hilditch, Managing Editor of Inside Housing Magazine, and today's session, in association with Rockwool, is about a topic of fundamental importance to people who own and live in blocks of flats across the UK. In a moment, I'll be introducing the lineup of experts we've assembled for you today, but first some details about what we'll be covering. As a reminder, the government announced it would materials in the external walls of high-rise buildings following the publication of the Hackett Review of Building Regulations last year. The Hackett Review, which was set up following the Grenfell Tower tragedy in 2017, surprisingly stopped short of the resulting outcry saw the government announce moves almost immediately. The ban, which came into force in December on buildings over 18 metres in height, is what will be, or part of what we'll be talking about today. And yeah, the session will be looking into what that means for providers, along with a range of issues that it's vital that social landlords are on top of, including the toxicity of materials used in their buildings, and problems that keep cropping up when it comes to things like effective cavity barriers. There are still plenty of questions to ask about buildings under 18 metres and existing stock too, so lots to get through. We're hoping to have a practically focused session, so advice that will guide your thinking and help you carry out your jobs effectively. The ultimate goal, of course, is to help make the UK's housing safer. So that's what we'll be looking at today. Our experts primed to deliver their thoughts to give people ideas about how they can deliver on their responsibilities. And that's probably more than enough for me. It's time to introduce our panellists. So first up, we'll be hearing from Professor Richard Hull, Professor of Chemistry and Fire Science in Lancashire. Then we'll be getting thoughts and advice from Tim Vincent, Head of Technical with Rockwool. Ashley Theakston, Associate Fire Safety Engineer with PRP. Presentations will be just over 10 minutes each, but this session is about the audience as much as the speakers. So if you've got any questions at all, then please ask away, and panellists can either write the responses as we go along, after they finish their presentations, or we'll pick up as many as possible in the question and answer session that will follow those presentations. Right, that is more than enough from me. Richard, it's over to you.
Thank you very much. After the immense tragedy of Grenfell, I think it took us all by surprise and shock. I think one of the issues that became apparent was that MHCLG hadn't kept pace with the way buildings had changed and what buildings were constructed with. And one particular aspect of that is the fire toxicity of building products. And as we go through, we can see that building products typically are, I'm hoping that this will change the slide. Otherwise, Martin, if you could do the next slide for me, please. Thank you. Most fire deaths are caused by inhaling toxic gases. A lot of those result from furniture in people's flats, but we can't control what people put in their flats. We can ensure that the buildings that they live in are safe, and we need to ensure that the toxicity of the things that you build buildings out of isn't going to affect their ability to escape. The toxicity depends both on the materials and on the fire conditions, particularly how much air is able to get to the fire, or whether enough air is able to get to a fire. And there is no requirement at all to assess the smoke toxicity of any building products outside of China or Japan. Could I have the next slide? So just as a reminder, in Grozny, they had the same aluminium composite with polyethylene filling and the same spectacular fire spread, but they had non-combustible mineral wool insulation, and that meant that the building, nobody died, the building was able to be refurbished and was back in use after 2 years. That's the building after the fire. At the Address Downtown Hotel in Dubai, the same thing happened. There was no insulation, but you had the aluminium composite with polyethylene, and it burnt around the building in a spectacular fashion, but again, there were no deaths. At Grenfell Tower, the combination of the aluminium composite PE with foam insulation led to 70 deaths. So I think we need to have a look at some of the factors around that. The first is the way the fire spread around the facade. I'm sure you're all familiar with these pictures, but it's interesting to see that once that fire belt has moved across the facade, it leaves every flat burning. And that's how the fire got around the building. If we look at the facade itself, it's got this 3 millimeters of polyethylene, and then you've got this cavity which acts as a chimney, and then you've got 2 pieces of PIR insulation foam, and then at every floor you've got some stone wool fire stopping insulation, which in the event of a fire should expand to seal that cavity so that the fire can't spread vertically upwards through the cavity. Now, obviously, when you've got the aluminium panel, it's not going to be able to withstand much fire, and so the fire can just get around that barrier, because if that's burnt through. But if that barrier fails to expand properly, it'll also allow the fire to get through. So I did a quick calculation on the heat release. The polyethylene should release 122 megajoules compared to the PIR, even though it's much thicker, is a lighter foam, and that would yield 132 megajoules. So you'd say roughly equal heat release from both the insulation and from the polyethylene cladding. When you look at the flammability, people will tell you there used to be adverts on YouTube showing that PIR didn't burn, and this was the demonstration that they used with the blowtorch. After 5 seconds, 10 seconds, you're using a fairly severe ignition source, you're blowing the flame out, and after a couple of minutes, you actually don't have any burning because you've created this protective char and you've blown the initial bit of flaming out. We did a different experiment, and this was actually on BBC's Panorama programme, where we just had a piece of ACM, heated it with a small flame, and got a few burning drips of polythene. And after 3 seconds, you can see the fires starting to take hold on the PIR. And within 40 seconds, you've got the PIR is burning completely, just showing how easy, if a gentle source of ignition is applied, it is to get it to ignite very much more vigorously. We've done a study using a cone calorimeter and toxicity measurements on a series of insulation materials, some with the same trade names as the ones used on Grenfell Tower, so probably the same materials, and then compared them to a couple of non-combustible materials. So first of all, here is the heat release. This is the cone calorimeter, which is really an over-enthusiastic kitchen grill. PIR insulation gives this sharp peak of heat release and then subsides to a fairly low rate of burning. Phenolic foam insulation gives a lower peak of heat release, but then subsides to a higher steady heat release rate. So both of those have a potential to be quite hazardous in a fire. If we compare them with the mineral wools, they're non-combustible. Most of it, apart from some binder, is something that will never burn because it doesn't react with oxygen, and therefore you get this very low level of heat release continuously. And that's why at the Grosvenor Tower it didn't combust, because there was nothing there to combust. So now let's try and understand the fire and the victims, because there were reports of people collapsed and dead on the stairs, so they'd been trying to escape. Some survivors were treated with this cyanokit for cyanide poisoning, including a woman who was 8 months pregnant, lost her baby. And when you're exposed to cyanide, it increases the respiration rate, which then means that you become unconscious much more quickly. So here is a typical, should be here, a typical dose response curve for carbon monoxide. So at a high concentration of carbon monoxide, you're unconscious very quickly, and at a low concentration, you're unconscious after 30 minutes. If you compare that to hydrogen cyanide, instead of that curve, you've got an almost constant relationship going from 100 just after 2 minutes at 200 parts per million is enough hydrogen cyanide to make you unconscious. And so it seems very probable that a lot of the people at Grenfell succumbed to the HCN coming first from the insulation before anything within their flat had burnt, and that made them unconscious, and that then prevented them from escaping. We measured the toxicity of these materials. I'm clicking for, so it just shows that HCN causes rapid incapacitation at low dose. If we can have the next slide. This is how we make estimations of the fire toxicity based on chemical analysis. You don't need to go into this data, but the concentration of HCN raised to the power 2.36 shows this non-linear relationship between the concentration and the effect on incapacitation. And we've then got some estimations of the fire toxicity, and you can see the big effect from the hydrogen cyanide compared to the smaller effect from the carbon monoxide. Similar for the phenolic foam for the carbon monoxide, and almost no effect for the non-combustible materials. And this is reported in a peer-reviewed Journal of Hazardous Materials, and you can click on that link and download the paper. So in terms of incapacitation or in terms of lethality, you can see that the greatest toxicity comes from the PIR foams, high toxicity comes from the phenolic foams, and much lower toxicity comes from the mineral wool. Now, can we say if this is relevant to facades? So we did some tests, and I haven't really got time to go into the details, but we did some tests on rain screen facades, the first one using stone wool and the new compliant ACM A2. So this is a compliant facade combination. We've got a wooden crib burning here. You can see how the fire has torn through all of the ACM, even though it's non-combustible, leaving the mineral wool behind. If we do the same thing with PIR, you can see that the fire attacks it, and then it's also destroyed a significant amount of the PIR foam behind the ACM, even though this was fire stopped here and fire stopped around the fire combustion region. And the same with phenolic foam. Again, we lost a lot of the phenolic foam, and we did one test with polyethylene filled A2, and we had to stop it after 12 minutes because the laboratory were worried about the structure of the test room that we were doing it in. You can see again, even after 12 minutes, a lot of damage. What I wanted to show you was this. We did some work measuring the toxicity from the kitchen vent, and this is reported on the FPA website. So we had on the mineral wool, behind there, we had a duct which was going all the way through to the back. So you can see here, that's the same duct as here. Then there's a long pipe going through here, and then a vertical chimney going up at the back, and then a vent on the front of the ACM panel, which you might have seen in the earlier slide. And then we took samples and measured the airflow through here, and we could see very high levels of toxicity once the fire had broken through into that section of the facade. So the oxygen concentration goes right down. In this case, it fell to less than 0.5%. The CO2 concentration goes up. The carbon monoxide and the hydrogen cyanide go right up, well beyond the lethal levels. So incapacitation would be almost instant at that point. And we just did a calculation on the lethality here to show the big difference between the PIR insulation. The phenolic foam was also bad compared to the stone wool. And so in conclusion, when a product burns, the greatest danger is from the smoke toxicity, and the emphasis on insulation over fire safety has left the building regulations well behind modern building practice. And in this revision of the building regulations, we need to ensure that smoke toxicity is adequately addressed, and it can be done so easily and should be an essential component of a fire hazard assessment. So that's me finished. Please feel free to use my email, send me emails, and I will do my best to respond to them or ask questions via the panel. Thank you.
Thank you very much, and a nice prompt there as well. Please, there is a question box, chat box to the right of your screen. So if you've got any questions for our panelists or any issues that their presentations raised that you want to pick up on, then please use that to ask questions, and we'll, like I say, we'll pick up on them as we go along in those boxes, and I'll try and pick up on as many as possible after we've finished. Right. Thank you very much. Excellent presentation there. We've had some technical issues today behind the scenes, so I am going to move to Tim Vincent, Head of Technical with Rockwool, and I'm hoping, Tim, you're on the line and ready to go. And if not, we'll skip along. But Tim, it's over to you.
Yeah, no problem. I'm here. I hope you can hear me.
Loud and clear. Yeah, good to go.
Perfect. Okay. Sorry about that. Bit of excitement for the morning. Okay. Right. Perfect. Hopefully everybody can now see the slides. I'll jump to the first slide in a second. Okay, so this is a bit of a look through the actual regulation and what the government ban that came out late last year actually means in practice. So approved document B, as it is written, or as it was written before some revisions came out, looking at the external walls of a building shall adequately resist the spread of fire over the walls and from one building to another, having regard to the height, use and position of the building. We've also spoke a lot about facades here, but it's also important to look at or to bring the rest of the building into question. And ADB also says that the roof of the building shall adequately resist the spread of fire over the roof and from one building to another, having regard to the use and position of the building. However, and my slides seem to be running a little bit behind time here, so bear with it. It will in a second say that ADB is currently being put up for revision and is out for an evidence call for public consultation until the 1st of March. So I'd recommend anybody who has views and has evidence for this to take the government up on their offer and to actually put some evidence in for this. Just waiting for the next slide to come along. Okay, so in regulations that were laid out in Parliament on the 29th of November 2018, we now have a legally binding effect to the combustible materials ban announced by James Brokenshire, Secretary of State, back in the summer of 2018. So combustible materials, and those are defined as those that are not of A1 or A2 on the Euroclass scale. So A1 being non-combustible, A2 being of limited combustibility in England and Wales, or non-combustible if you're in Scotland. So combustible materials will not be permitted on external walls of new buildings over 80 metres containing flats, in addition to new hospitals, residential care premises, dormitories in boarding schools, and student accommodation. Okay, sorry, just waiting for the next slide to come along. Okay, so understanding the product combustibility, how do you, sort of alluded to it just in the previous one, but how do you actually know what is what here? So the combustibility is to a Euroclass EN 13501, which gives you the Euroclass A1 to F, or no performance determined scale, which you can see on the right hand side there. The 13501 test, as I've touched upon in some of these seminars before, looks at the ignitability of the product, the flame spread, the heat emission, the smoke and toxic gas emission, and also the character changes, e.g. melting, dripping or charring from that product once it's being tested. And you can see the combustible range here. So anything that has got a B on the Euroclass scale right the way through to F, or the MPD as we call it, is actually classified as combustible. Now the next slide, when it pops up, will sort of then bring the ban into context of this. Bear with it. Oh, I decided to do it in a different order. This is how you find out how the product is classified as non-combustible, combustible. You need to look at the declaration of performance that all CE marked thermal insulation products will have, and all manufacturers will have these publicly available on their website or upon request, but most of them are publicly available. You'll see a copy of the Rockwool DOP on the left-hand side. And if it ever decides to enlarge, the key piece of text will actually show you the reaction to fire classification for the particular product in question, which for all of our base slab insulation material is A1 non-combustible. As you can see there. So, as I said before, the building type and compatibility in terms of the actual government ban that came in. So the high-rise buildings that contain flats, hospitals, residential care premises and student accommodation, all of which high-rise, will need to now fall into the A1 or A2 categories. So in terms of purely insulation, that will mean you will need to go to a glass wool or a stone wool insulation product. Other products can then be used on the other building types in accordance with current ADB guidelines, or ultimately going through a large-scale test should you wish to use the combustible products. As you can see here, these include the plastic foam insulations. And as we always say, if you're unsure, don't take my word for it. Check the Declaration of Performance certificate that's out there. This will give you the full crystal clear guidance, and you can see for yourself without having to rely on us. Now the slides seem to be going backwards again. Please bear with me, people. So currently, as approved document B stands, you've got option 1, where when the table approves, you will see it in a second.
I think we're having a few technical problems with that presentation. I think we've just lost Tim there. Ashley, we might actually just move to your presentation now, if that's okay, while we try to get Tim back on the line. Ashley, we will now move to you and move through your presentation, with apologies to everybody for the break halfway through Tim's there. So Ashley, Associate Fire Safety Engineer with PRP, and over to you and your presentation now. Thank you.
Lovely, thank you. Thanks, Martin. And good afternoon, everybody, and thank you for the opportunity to Inside Housing for the opportunity to present this afternoon. Just for a little bit of introduction, my background's in fire and rescue service, significantly within a fire protection department. Obviously undertaking fire customers for a number of years, with the last 5 years fire engineering consultancy. Okay, so just moving through then. Okay, areas. So areas we want to have a look at this afternoon, something for in consideration, and other subject to some of the slides. So why have so many facades been found non-compliant? So we've what I can present here is a misunderstanding and interpretation of the codes, the guidance, as I said, with lots of references to the approved document, competent assurance, with regards to test and certification, product marketing and test claims, compliance, obviously, change process, and with regard to this, the design, the build process along the way, things that have been maybe put in the look at the products that might have been mentioned in the fire strategy, initial fire strategy, the design, obviously the layout of the building, and it may have changed and not been identified along the through the design or the construction stages. Workmanship and installation, yeah, lots been said about this one, isn't there? Okay, we're there. And the final one there, the quality control, clock of works, building control body, fire service comments. Should they be involved a lot earlier? Lots been said about that as well. And there's their representations, and probably aware of the fire services saying they want to be involved a lot more, and site inspections. So for us, as far as PRP, what we've done, I've been involved in the last year and a half, and actually going down to sites. People, contractors saying that our products are always branded. And what we've discovered is that around about 90%, and the next slide will come up. About 90% of the products we've reviewed have been unbranded rain screen insulation. So something going to miss there with regard to the testing process. That gives cause for concern. The fact that the products there unbranded and gives cause for concern with regard to the testing process those products have gone through. Competency, you mentioned this at the beginning. Competency, cavity barriers. 2 or 3 examples there. say the one on the left where the actual Rockwell installation is, you know, unfixed at all. No no perforations. Actually, you know, the skim, the waterproof membrane. So words I'm looking for, waterproof membrane, nothing in there, but actually fundamentally it's actually not fixed correctly in place. And then the one on the right, we've got actually, you know, standard loft insulation being dropped in there, and again not even fixed, but actually the wrong materials, and just one in the middle there. Just again something I've seen on the fire risk assessments. All right, all very well, but yeah, nice little plastic sheet as the fire resistant materials. And this next slide talks about similar to the same fire stopping materials. You got one on the right there. You got ventilation ductwork and vents for the actual materials. The fire stopping materials incomplete around, not necessarily with the correct materials, but certainly incomplete. That's what we found. And maybe a standard photograph that I know probably many listeners have experienced. Maybe correct materials, but incorrectly fitted and not just not finished. Just poor workmanship. That's it. The slide says number of existing buildings we've reviewed having compliant cavity barriers. None. We haven't seen any in our projects. Certainly in the last 18 months we've been able to calls to go back and have a look at. So none of those have had compliant cavity barriers. But this one, so again, quality record information, drawings and specifications, test reports, absolutely fundamental, isn't it? There's lots of mention around test reports. Who would have thought that fire testing had been so interesting? But formal written assessments, fire strategies. Presented on drawings or written format. Yeah, really expects to see fire strategy in a written format, but you know, it might be a small and relatively simple building, and you know, the design, the architectural practice, it's just presented on drawings. You know, but does it state, is it just materials, or does it actually state fire strategy related aspects regarding B1, B5? Okay, changes the records and also site installation records. Their number of projects again reviewed and completed drawings at 0%. I won't say any more than that. A completed record drawing at 0%. And these aspects there, digital records likely to come out of the hacker review. Again, so this already been touched on by Tim, so I want to dwell on this too much, but really just reminder really the advice note 14 that came out on 18th of December, stuck in just before Christmas. So it concerns the fire safety external wall systems and the buildings above 18 meters in height that do not incorporate ACM. This includes tall buildings that incorporate any form of external cladding system, even those comprised of limited combustibility. So the response to this note could be seen that the government snuck in a little bit of retrospective obligation to this. Certainly getting through discussion and media around the note. But fire safety and external wall systems, that the note talks about, is the external wall system safe? Has it achieved BR135 classification by a successful test, 814 test? And seeking advice whether these materials are of limited combustibility. The PRP, we attempted to summarize. So you can see some of the people that have seen the note 14 will recognize some of the boxes here. We tried to summarize this in a sort of a little bit of a flow chart. So skimming through this one, 914, it says out what do we know? New buildings, facade refurbishment, as Tim's already said, is over 18 meters. You can see in there residential, hospitals, residential care, student accommodation, including dormitories and boarding schools, sorry. Insulation products are to be considered. The ban applies to all new buildings where new building or where building work is carried out on a building, having a story above 80 meters or more above ground level, which contains those types of properties. So it's new buildings, facade improvement, facade refurbishments. So we've had many inquiries on this, certainly, and since the beginning of January. So what can be considered to include? The whole wall, timber frame, structural insulated panels, and CLT, lining boards, membranes, and particularly balconies. Balconies have come up, and there's a couple of cases I'm just going to quickly move on to shortly. Considered to include timber decking, so fixtures to the facade, rainwater pipes, ventilation grills, shading devices, but at the moment not roofs, but it's under consideration within the review. So what does this mean for occupied projects, for projects under construction, for projects in design, projects even in planning, and obligations to remediate? Perhaps the most significant advice in the building notes to create a retrospective obligation on all tall building owners, not only to check the external wall construction, but also to remediate any wall that is not safe. That's the word that's mentioned. What's safe? You know, what's the definition of safe? Moreover, an external wall system is not safe consideration will have to be given appropriate mitigation measures till such time can be deemed safe. In this regard, the note confirms that the advice the Garnets previously published in respect to all buildings with ACM panel would apply to other external wall systems. So ensure what mortgage companies' response to this, they've written to all building owners to say to them they must prove compliance with BR 135. Meaning a full-scale fire test. The ban has stopped the test. No longer be able to refer to that test. So it's difficult to prove compliance. But certainly that's of great interest to banks and mortgage providers. So regulatory reform then. So looking, this is up for discussion as well and for considerations. So building owners responsible for fire safety of the buildings. Tall buildings owners should be commissioned assessment of the external wall construction. And also the new regulatory regime is likely, certainly our view in its in the industry is it's expected. So the advice note rightly identifies the building owner as a responsible person, and they're responsible for the fire safety of the buildings. So while it's currently uncertain in many ways, place a decision on the responsible person to appoint a fire safety advisor to derive these new obligations. The existing duty to take general fire precautions. The Ministry of Housing made it clear the new regulatory regime is unlikely, however, which is an interesting touch on that. I've certainly been contacted by a couple of forest assessors, registered forest assessors, and said that their process they're going through for the registration is likely to change, and also the PI insurance that they may have, the insurer checking that they've got they're competent and have got knowledge of external cladding systems. Okay, so practical steps owners should comply with Advice Note 14. Identify your tall buildings. Many clients are responsible for hundreds, if not thousands, of residential buildings. It will be necessary to identify which of these are tall buildings. Prioritize your investigations. If you have several tall buildings, may seem difficult to start, but you might consider the number and vulnerability of occupants. Levels of risk. Go on to the third one, locate all records, as built information. This is a difficult one. You may need to understand the build-up of the system. As built drawings should also contain this information. If you do not hold the copies, request them from somebody who might, for example, the employer's agent or the original contractor. Confirm what materials make up the system. Record your drawings and other technical information, including external panels, frames, insulation, cavity barriers, etc. And of course, seek advice on whether these materials are of limited combustibility. Materials of limited combustibility are derived by reference to the building regulations as they are at the moment. Okay, a couple of little case studies. So construction materials. Yeah, this was in the a lot of media attention around this one. Manchester City Centre back in December 2017. So just a few days before the Liverpool 1 car park fire. You may remember that one. So again, construction materials, but began on fire. It's believed to have begun on the balcony and infected the upper floors. Again, this one here, West Hampstead summer last year, our balcony started fire controlled by the sprinkler systems within the flats. So no surface spread or evident cavities barrier spread, but resulted in full building evacuation. Okay, just to summarise the last one. So again, there's a lot said about the beginning, misunderstanding and interpretation of codes and guidance, competency and insurance, test and certification, product marketing, test claims, and again, compliance, change process through the design and construction phases. Workmanship and installation is absolutely key, and obviously, and finally, remaining absolutely key is quality control. Establishing an effective, competent, and assured clerk of works process, involving building control bodies and any fire service comments. And again, just to finally, will Will it consider the installation of fire evacuation alarms? That's the thoughts. It's been suggested. I've heard and discussed to the communal areas for operation, perhaps by the fire service, cause and effect of lifts and their utilisation in the event of evacuation. Stronger requirement of the fire rescue services to liaise more effectively with high-rise residential building owners. Just a couple of little references I've taken. Okay, yeah, just really that's about it really. A couple of little references there you may want to have a look at, but certainly would draw your attention to the Barber Lane presentation just at the bottom there. That's on the inquiry recently last summer. Okay, thank you very much. That ends my my presentation. Please feel free to message me, email, or on the Q&A session shortly.
Fantastic. Thank you very much for that, and thanks for stepping into the breach there as well. Much appreciated, and lots to pick up on there. And we've got some questions that are coming through, so I'll try and get through the audience's questions as much as possible, and some of my own as well. So thank you to everybody for presenting there. But we're going to move to the question and answers now. Somebody has asked us if the presentations are available after the webinar's finished. So yes, you'll be able to access them after the webinar. They are made available. So yeah, you can go back through and have a look through those presentations. Lots to pick up on, and I'll pick up on a question from our audience because again, this is about answering as many questions as possible from people who write in. So if you've got anything, please use that question chat box on the right hand side of your screen. Ask some questions, and we'll pick them up. And I think that was relating to your presentation just there. So I'll come straight back to you, Ashley, if that's which was which standard should the test on rain screen meet, the British standard or European? So yeah, Ashley, if you want to go with that, or anybody else who wants to come in. So Ashley.
Thank you, Martin. Thank you to the question for that one. I would go to the British standard at the moment. It's I'd have to seek advice from a colleague in all fairness, but I would at the moment the appetite would be for the British standard, and then to see what comes out from the approved document and something of the code of practice from industry. But in this many things to be changing from week to week, but I would stick to British standard at the moment, and then but I'll say I welcome any other panelists' comments, but I'm happy if that questioner wants to email me and I can get back to them properly on that, if that's okay.
Thank you very much. Sorry, another question that's come in, which is a very specific one about so this is an organisation that's got a 1970s high-rise building in the northwest of England, 15 stories with windows due for replacement. They were considering using PVC, but because a set of windows per elevation have infill panels, windows are continuous from ground to roof, and we're now scheduling to use aluminium. Is this something the panel have experienced and would expect? So quite a specific question there, and I don't know whether Richard, would you want to come in on that, or?
Well, I'll come in on both the previous question and this question, in the sense that aluminium, although it's a very good product for many things, in the event of a fire, it melts at 660 degrees, which is typically below a fire temperature. So any size of developed fire is going to mean, and if you saw the presentation, that towards the end of my presentation, I showed the aluminium A2, which is the now compliant thing that you can put on a high-rise building, and it offered no fire protection at all from a developed fire. So if you had a fire in one flat, then you would imagine that aluminium would allow the glass to drop out of the windows, which would certainly, the aluminium isn't going to contribute to the heat release from the fire, so it's not going to support fire spread in the same way that combustible facades would. But there is a potential danger with aluminium. On the other hand, PVC burns, and therefore PVC will support the combustion. It also produces hydrogen chloride as well as benzene, which is carcinogenic when it burns. And is going to affect, actually the hydrogen chloride affects adversely the toxicity of other products. So I don't know what the answer is, I'm afraid. Very unhelpful, sorry. The problems with aluminium are the melting, and the problems with PVC are the melting and the burning. And PVC, as was reported by Jose Terrero at the Grenfell inquiry, yields at about 100 degrees, and therefore it loses its structural integrity. So I guess your aluminium that's going to maintain its structural integrity to 660 degrees is going to be vastly better.
Understood, and very useful. And I think it also goes to show just how complicated and I guess why we've got so many people tuning in today with questions, how complicated they are to actually push through and answer. We've got another question coming in from one of our audience today, which is about enforcement and about what happens moving forward, I think. And it says, how do you think enforcers will assess what is safe and what isn't? And then goes on to ask, do you think they will try to calculate the overall fire loading? So Tim, I'm going to try. I think is back with us, but I'll throw that one to you. So Tim, are you on the line? Can you hear us? In which case, I will move on to Ashley. But while we're mentioning it, Tim, because we've had these problems today, hearing Tim, we've got his email address, which he's asked us to give out. So if anybody does have any specific questions, please just get in touch with him directly. And apologies for the sound issues we've had with Tim today. So it's tim.vincent@rockwool.com. So if you've got any specific questions you want Tim to answer, he's happy to pick up on them separately at that address. Right. So that question about enforcers, enforcement, and how that's going to work. Ash, to take over on that, please.
Okay, thank you, Martin. Yes, I think as a former regulatory officer, some 5 years or so ago, of course, one or two things changed. I do keep in touch with colleagues. I think in my experience as a fire consultant in the last 5 years, it's become very risk averse is the terms that's often used. Risk averse to actually making decisions, if I can say that. And apologies for one or two regulators that may be listening to this webinar, but you know, I was only just having a conversation on the train coming into work this morning where somebody's has got an arrangement with the primary authority, and just so difficult to get a decision out of them. And I equally had the same conversation with another client with actually it's the same primary authority, but yes, and that pushing maybe decision back to the client, the designer, the assessor, the owner. It's an awkward one, and I think they should sort of hang their hat on a decision and give some appropriate and some reasonable advice. But I think they're under pressure to have resources and correctly train, and appropriately trained resources that have got the confidence and the capability to give, what's what I call assured advice, isn't it? But hopefully that maybe gives some thoughts to the questioner. But again, feel free if they want to email me. Likewise, I'm happy to communicate with them.
Thank you very much. And yeah, the questions keep rolling in. So I will, like I said, I've got plenty that I can run through on my own, but I want to get through as many of the questions from the audience as so there's a question about the guidance on the combustibility of windows or size of windows in high-rise blocks. I mean, again, a really important issue highlighted from Lacanau through lots of other examples, unfortunately. Richard, I'll move back to you on that one in that case. So questioner is after guidance on the combustibility of windows or size of windows in high-rise blocks.
I'm sorry. Could you say that again? I missed the
So
question.
this is a question from the audience, and they're particularly concerned with the combustibility of windows. So what guidance is out there when it comes to the combustibility of windows or the size of windows in high-rise blocks? So I guess it's quite a general question, but what guidance is out there that they should know about in order to inform their decisions?
I'm a materials chemist, so I know how things burn. I'm not concerned too much with the regulation and what is allowed. What I would say is that if you take timber as a material, when it burns, it produces a char, and so it slows the rate of burning. And when I was answering the question about the aluminium and the UPVC, I thought, well, if you had a timber window frame, the chances are it would survive longer, probably at 660 degrees, than the aluminium would. In terms of once the window breaks, then you're allowing more oxygen to get to the fire, and that's going to then cause greater and greater fire spread. So the most important function for the window, and effectively it's like a curtain wall, you want your walls would be made to withstand a fire for 2 hours, but your windows are going to be the weak point that's going to let the oxygen in. Once the oxygen's in, then the fire is going to grow at a much greater rate.
Thanks very much. And Ashley, I might bring you in on that in a second. But there was, from your presentation as well, there was some issues raised, which and I know we had a chat about this in advance, about products on buildings and kind of worrying that they're perhaps not what people thought they were in a lot of cases, and not the brands that people thought they had there. Again, can you just how widespread that problem is, what people should be doing, if they've got any concerns about this, and what kind of checks, how we should be introducing those checks and balances into the system?
Well, I suppose the checks and balances are there. It's our many people now becoming aware that obviously I need to check that. I mean, it's those data sheets that are provided by the manufacturer, the installer's records, what they installed, what they're installing, how it needs to be installed, that's prescribed by the manufacturer. Those test records clearly need to know what they're expecting to receive and what they're looking for on that data sheet to tell them, actually, yeah, I'm happy with what I've scoped to have fitted. Obviously seeking consultant advice if you need further due diligence on that. I think it's
and that hasn't been happening. We think where do we think the gaps have been in the process that's enabled some of those problems to arise?
I think speed of build in my experience, the regulatory bodies, they're trying to maybe control the size of a building, the design of a building too late in the process, in the construction process, and they're putting the slates on the wall, and the fire service have not sorted out water supplies and access yet. It's far too late, and the building is being built, and they're moving on. I think it has been a difficulty, and I think what I want to also touch on, if I can, and just finish on that one. It was the products, of course. In a high-rise building, let's make the window frames and the spandrel panels. I mean, there's lots of obviously the device note on spandrel panels as well. The panels below and to the side of window frames. The questioner could say, well, I'll make my my window frames have steel work. Well, what about the glass? The fire's still going to spread via the glass, whatever, regardless of what we make the window frames out of. And then it's how those window frames are actually mounted in, fitted and installed into the walling curtilage itself. And that's where problems have arisen, isn't it? You can have maybe non-combustible, but you can have a fairly fire-resistant materials. Richard mentioned timber. but then is it cavity stopped as well? Is it allowed to is the fire allowed to sort of get into the cavity, and is it stopped at the barriers of the flat of the compartment? So but yeah, so a fire is designed to stay within the flat, but yes, fire could spread via the glazing, and obviously generally just travels up to maybe 1 or 2 flats above, but the people can turn away from any issues and walk down the stairs. So there's a cumulative and a combination of other factors, isn't it? They must be able to walk away from that from the window and go out the flat front door and down the corridor and along down the staircase.
Thanks very much, and I'm going to move to one last question, if that's okay. And this one's for you, Richard, raised from your presentation. And obviously today we're spreading learning, but your presentation referenced earlier fires in Grozny and Dubai, and I just wondered, are we getting any better at sharing and picking up on this learning? Because clearly there was huge amounts of learning and information out there before Grenfell that didn't reach the appropriate places. Are we getting any better? And what needs to be done in order to make that process easier? So we're not just picking up on learning in this country, but further afield, and making sure that is quickly, the best practices spread widely. So Richard, over to you on that one.
I'm really not sure that I'm the right person to answer that question. I have had some interaction with, if you like, policymakers and so forth. Previously, I've just existed quite quietly as a chemist, working away in my lab and publishing papers. And I think in the main, people didn't take any notice of the publications. The world has woken up.
Clearly they should, and hopefully we are now. I just wonder where you think perhaps those gaps are, that we can make that process easier in terms of that spread of information, because that to me seems to be one of the many failings that led to Grenfell, and has led to numerous failures over the years, that there's just not this transfer of information. Any ideas you've got about how we could get better at that would certainly be gratefully received.
Sadly, I don't think I've got it. I mean, I can see that if all the information was available in a central location without too much irrelevant information, then people would find it much more accessible. And at the moment, there is no such repository to do that. One can hope that the new revision of Approved Document B will be a master of clarity and precision, and only say the things that you need to read and not have things that you don't need to read in it. But this is an enormous challenge, and it's going to take a long way. And with materials being developed, new materials for building being developed so quickly, for regulations just to keep pace with those new materials is going to be a challenge.
I don't know if I can just jump in there, please, Martin. I mean, just while there's still a number of listeners online. I mean, for me, as an example, it's an interesting and it could be how long's a piece of string type question. Where is this information? And I've said to people over many months, and I'm not sure if there's going to be a Grenfell Act 2017 that's going to come from it, because I think there's maybe as has been in the past. We got fire safety legislation because of what's happened in the past. I'm not quite sure if personally speaking, whether there'd be a Grenfell Tower Act 2017 that'll come from it. I just think there'd be maybe a tightening up of lots of things that are already there. And you say, well, we in the industry know where there's information to be gained, and to give assured advice to the property and the design and the audience, I suppose, the design team at the time. I think maybe a couple of things to add to that. I mean, Institute of Fire Engineers are running an Approved Document B workshop been held at the PRE next Tuesday. I think it's just for IFE members, but because Tim mentioned has pointed out before he went offline, the 1st of March is a submission date for the pre-document B review, comments. So the IFE are putting a workshop together of its members. And just to add to that, something along the lines with the fire engineers, there's a firefighter safety on the website, special interest group there, because the person that put that forward was a colleague of mine, Adam Course, was about the research in firefighter safety and incidents and case studies have gone on, and learning from the past, learning what's gone on around the, not just in the UK but around the globe. So there's and that mentioned the word repository there, to put these case studies online and make them available. So if people were, coming up with plans and operational plans or case studies, that they've got something to maybe and to look at and to learn from. Just to add that one there, so fire engineers, firefighter safety website.
Very, very, very useful actually. So thanks for that. And I should say actually we're because there's been a question about can there be an online forum of participants set up to continue discussions, and certainly one of the things we've been looking to do is set up a fire safety group to enable discussions certainly between landlords. So if anybody's interested in that, then please drop me a line, martin.hilditch@insidehousing.co.uk. Right, I think we have pretty much reached the end of our session. Apologies for the problems we had. I think they were weather related by the sounds of it with Tim there. But again, anybody who wants to question him on his presentations or ask any other questions, he's available at tim.vincent@rockwool.com, so drop him a line as well. Other than that, I'd like to thank Richard and Ashley for some absolutely excellent presentations and a question and answer session following that. So thank you to our panelists, and yes, I'll wrap up the webinar there now, and I hope it's been of use to everybody who tuned in today.